shift, or we call this actually a stretch or a compression, but that's the last piece of all this transformation stuff that we've been doing. Okay, so there's two types of stretches or compressions. There's vertical, which means that, I'll just do a basic example here. Let's say I have these 2 points. Okay. Can you guys see what the y coordinates are for these 2 points?
1, 1, and 2, 2.
Okay, so the y coordinate is 1, the y coordinate is 2 for this one, right? If we had a vertical stretch, for example, if you see something like 2 times f of x, all that's going to do is double the y values. So this point would now go up to 2, and this point, which is already at 2, would go up to 4. Does that make sense? Okay. If we have a fraction out here, that's going to shrink what's going on with the graph. So for example, if we had a 1/2, then these y values get cut in half. So instead of being up at 1, this point goes down here, and then this point goes down halfway to 1. Okay? We'll do an actual example, but that's kind of what this is telling you. Okay? And the general rules are going to be, they have them here. So if you have a number on the outside of a function, okay, then here's the new point. Okay? So if you have a number outside of a function, you're just going to multiply that number to the y variable. Okay? If you have a number inside of the function multiplying x, then you're actually going to do the opposite of it and divide. Okay? And you're going to divide the x. So just to recap, let's just do all of these. Oh, and forgot about this one. Okay, so we've now talked about what all 4 of these things are going to do to the graph. Okay, so I'm going to write in words what's going to happen to our picture, but hopefully you guys remember some of the stuff from before break. Okay, do you guys remember what happens if in the function we add 2? What does it do? Bless you. Shifts left 2 units. Okay. What is subtracting 2 on the inside going to do? Right 2 units. Okay. What is adding 2 after going to do? There we go. Starting to come back. What is a minus 2 going to do? Down 2. And then these were the 2 that we just did. These are the 2 that we did before break. These are reflections. Okay? This is a reflection over the x-axis. And this is a reflection over the y-axis. Okay? And now here, you're going to take the y values times 2. Here you're going to take the x values and divide by 2. Okay, so these are the rules. Okay, I always like to think about, like on the inside, it's opposite of what you think it would be. Does that make sense? Like if you're adding, you're actually going left. Does that make sense? If you're subtracting, you're actually going right.
But does that say x value?
X values divided by 2. Sorry, that kind of...
But the first one's y value.
Times 2, yes. Y values times 2, x values over 2. Divided by 2. So anyway, back to what I was saying. in the parentheses, you basically do the opposite. So if you're adding, you go left. If you're subtracting, you go right. If you're multiplying, what's the opposite of that? You divide it. So that's why we're dividing the x values by 2. Does that make sense? If it's on the outside, you do exactly what it says to do, but to the y values. Okay? So for example, here, you're just going to go up 2. Here, you're going to go down 2. Here, you're going to multiply by 2. Okay? So on the outside, it changes the coordinates the way it should. On the inside, it changes the coordinates by doing the opposite. Yeah.
Good job.
Does the bottom two say
Reflect over x, and then reflect over y. Okay. So we're going to do, like, by the way, this example has 2 of these. It's got a x and a y change. You're probably, on an exam or a quiz, you're probably not going to ever have both at the same time. It'll probably just be one or the other. Okay? So let's kind of figure this out. So first, let's fill out this table. Okay? Take a minute or less, look at the picture, fill out those y values. That shouldn't be too hard. All right, so what are the y coordinates for -6?
3.
What about at -2?
-3.
0 is at
-5.
-5.
7.
2 is at -7. And 6 is at 1. Okay. So this is what we're calling the parent graph. Okay. The reason I'm calling it that is because these rules that we're going to do work for parabolas, work for absolute value. It works for every single function that we've studied. Okay. Let me use a different color now. The 1/2, is this going to change the y coordinate or the x coordinate? The y coordinate. Very good. This 1/2 is going to multiply the y values times 1/2. That's what this does. Okay? On the inside, we do the opposite, though, right? So what is this doing right now? Well, it's multiplying. Yeah, you answered my question. It's multiplying x, so the new coordinate is going to be divided by 3. So this is going to take x and then divide it by 3, and then this is going to be 1/2 times y. Okay? And so once you have these 2 rules, or at least you know what's going on, I like this. You just look at the table and just rewrite your new coordinates. Okay? So let's do the x values first. We're supposed to take the x values and divide them all by 3, right? So the new column should be -2, -2/3. 0 divided by 3 is still 0. 2/3. And 6 divided by 3 is 2. And now my y values are all getting multiplied by 1/2. So what's 1/2 of -3? What's half? Oh, and that's the same. 1/2 of this one. Here it's -3.5, and then 1/2 of that is 1/2. So after these 2 rules get applied, the pink values are the new coordinates that you're going to graph. So if we just take some time and graph this carefully, the new x value is going to be -2. The new y value is -1.5. So like right there. And then we go -2/3. These are by 2's, right? So -2/3 will probably be right around there. And then -1.5 still. 0 went down to negative 2.5. So that's right about there. Two-thirds, right about there. And then negative 3.5. So somewhere like that. And then 2 is now at 1/2. So your graph now looks like that. Okay? So this is f of x right here. And this pink one is 1/2 f of 3x. Okay? Are there any questions on how we did that? I would not expect any of you to just like look at the picture and just on the fly go, yep, that point goes there, that one goes there. It helps if you have a table and you just rewrite all the values and then you just kind of break it down like that, a step at a time. Okay? Any questions on that? All right, let's take a look at the next. Oh, we did that. Oh, good. Here's some review stuff. Okay. So let's actually just work through this page. This box has it all written out for everything that we've talked about, how the numbers on the outside do certain things, numbers on the inside do certain things. It's all written for you in case you need to go back and you forget. Okay? Now, proper order. So if there are any, or if there's more than one thing that you have to do, okay, the order that you do things in is reflections first, then stretches, and then translations. Okay? Reflections is what we just did before break, where you flip things over X or flip things over Y. Stretches we just talked about. The translations is the left, right, or up, down stuff. Okay? But this is the order that you go in. I always remember the abbreviation RST so that I can kind of remember it that way. I don't know if that helps or not. Okay? The last thing that we need to talk about too is right here. If there's stuff going on the inside, we always factor on the inside if possible or if necessary. Okay? So I'm going to do number 1. Okay? And I'm going to rewrite this. And here's a perfect example of factoring on the inside. Okay? If this minus 2 weren't there, I could just start figuring this out right away. Okay? But whenever there's a number in front of x and you have some other stuff going on with it, you want to take this 1/2 and pull it out so that you can actually see what the real translation is, because it's kind of hidden. Okay? So if you take out 1/2 from this first term, what should be in here?
X times 2.
X minus, and now here's the part that gets tricky. 1/2 times what number is 2?
4.
So this should be a 4. So this now looks like what kind of shift in here?
Positive. Or
Which direction and how many units? Right 4. As opposed to here, you might think, oh, we're going to shift right 2, right? So that's why it's important that you're always doing this. If there's a number in front of the x, factor it out because this is going to change. Okay? And so let's start by graphing the parent graph. So I'm going to do parent graph in pink. Parent is the cube root of x. Okay? Do you guys remember what that looks like? Okay, perfect. So you forgot, right? Can we figure it out on the fly? Like, what's the cube root of 0? Do we know that? So cube root of 0 is 0, right? What about 1? Do we know the cube root of 1?
No. That's one.
No, it's 1, yeah. Yes, it is 1. Okay. Do we know the cube root of 2? No. 2 times 2 times 2 is not 2. I don't know who said that. What's the next number that has a nice cube root? 27 actually does, because 3 times 3 times 3 is 27. 8. 8 has a nice cube root, right? What's the cube root of 8? So 8 is going to be up here at 2. Is the shape starting to come back? What's going to happen over here? It doesn't just go like that. We have points over here. You can cube root negative numbers, and it's going to just kind of go through the origin and go opposite of what it does in the first quadrant. Okay? So this is your parent graph. Okay? And now if it helps, you could even draw the table. And honestly, you guys, I'm just more worried about the shape. As long as you have these 3 points, so like -1, -1, 0, 0, and 1, 1, that's good enough to figure out what the new graph looks like. Okay? And so I'm going to do that in green.
Shifted up the colors.
Why is the third point at 1, 1?
Because that was a point.
Oh, so we're not doing 8.
We're not, what do you mean? Oh, up here?
Yeah.
I mean, yeah, I didn't write it down. I just wrote these main 3 in the middle. But yeah, that's still there if you want to put it in there. Okay? All right, so let's see if we can do this. Are there any reflections in this new graph? Yes or no? Somebody said no, and I agree. Yes, question?
How do we know if it has a reflection?
That's a good question. In order for there to be a reflection, there's got to be a negative in front of the entire function or a negative in front of the x. Okay? So if we don't see negatives in front or of the function or in front of x, there's no flipping involved. Okay? So no reflections, so we're not going to do that. Stretches, those are the multiplying and dividing things we just talked about, right? Do we have any of that going on? Yes, right? We have a, so first thing I'm going to do, since there's no reflections, is worry about this 1/2. The 1/2 is what stretches or compresses the graph, right? So remember what we talked about? What's the opposite of taking half of something? Multiplying by 2 or doubling. Does that make sense? And so the first thing we're going to do is double the x-coordinates.
Do that every time, no matter what.
Well, for this one, because there's a 1/2 there. Okay. The second thing we're going to do, is there any more stretching? I kind of alluded to the fact that there isn't. If there was a number on the outside here, we would have to worry about it. But we've taken care of the 1/2, right? The last thing we're going to do is what now? Translations. And we already talked about this -4. What does that do? Moves it right 4 units. Okay? So let's double all our x's. Okay? So my new x column is going to be -2. 0 doubled is still 0, but now 1 doubled is 2. And then my y values are going to stay the same. Okay? And so now that is going to go -2, -1, 0, 0, and then 2, 1. And so here are the new points. Okay, so currently I have something that looks like this. You guys see what I'm talking about? A little dotted green line. Let me zoom in. Okay, so after I doubled the x coordinates, these 3 points in the middle end up going here. It's still going to have the same shape, it's just going to get thinner. Does that make sense? And now what's the last step I'm going to do? Shift everything right 4. Okay? So take your new points and shift everything right 4 units. So this point is going to go right 1, 2, 3, 4. So is this one 1, 2, 3, 4. And so is that one 1, 2, 3, 4. And then now you just kind of copy the shape. Okay, so the blue is the final graph. Okay, that's actually one of the harder ones in here.
So the new graph would be like -3, -4, -2.
Say that again?
So you just subtract 4 to all the y values.
Add 4. Remember, it's opposite. We're going right 4, so the y values get added by 4. I'm sorry, the x values get added by 4.
So you just do the opposite of what it says.
Yes, to x. So maybe I'll write that table down. We're moving right 4, so this is now 3, 4, 5, and these points are still -1, 0, 1. So the green parent. So here's the parent. This was the stretch. And then this was the final one when we shifted right 4. Okay? We don't necessarily need to do all these, but let's do at least... Yeah, let's do number 3. Okay? So, number 1. I'm just going to write down the steps. Okay? Are there any reflections?
Yes.
Yes. Over, so we're going to reflect over what axis? Good. That's the first thing I do. Okay? That's the little negative on the inside, right? What else is going on? Down 2. Okay, I'm going to try to do this one without the table. Okay, let me actually use pencil real quick. And I don't have my pencil. You know what? I'll use it. Okay. So what's the parent graph here? X cubed. Okay. X cubed is kind of like this one, but the other way around. Yes.
On number 1, when you had in green, you had the graph as -2, 1, 0, 0, 2, 1. How'd you get +3 if you are moving right to the right 4? Yeah, shouldn't it be +2?
Should be 2, 4, 6.
Ooh, my goodness. Add 4. Yep.
Did you add it to the parent graph?
Yeah, I went here and added the 4 there.
That's what I was.
Yep. Thank you for catching that. So I was supposed to check the green coordinates. By the way, the graph is fine. So this should be 4. Or I'm sorry, I did it again. That should be 2, 4, 6. Thank you. We always reflect first, then stretch, then we shift the coordinates left, right, up, down. Okay? All right. Let's see if we can do this one now without making a table. Just because this one isn't too bad. There's only a couple things going on. So parent graph, 0, 0, 1, 1, 2, 8, right? And then we have the same thing going on the other direction. If you don't know your parent graphs, You got to review those, and that tells me that you probably didn't do your 3.4 homework because those were all in there, right? So here's your parent graph, all right? And now I'm going to do first step in blue for this one, and my final graph will be in pink, okay? If I reflect over y, where does this point go? It just goes across the y-axis over here. Does that make sense? This point flips over y. This point is already on the y-axis, so it's not going to move anywhere. But now these points go from left to right. And so here is, after step 1, now I'm here. Does that make sense to everybody? What's the final step? So now we're going to take all these points and just shift everything down 2 units. So this point goes down 2, that point goes down 2, this point goes down 2, that point goes down 2, and then this one is kind of off the graph, but that's going to go down 2. So your final graph is going to look something like this. Yes?
Why did we reflect for the first one?
Why did we reflect?
Why didn't we reflect for the first
Oh, here?
Yeah.
Because there was no minus in front. Thank you, I didn't understand your question. There was no negative in front of x, and there was no negative in front of the radical. Here we have a negative right in front of the x there. Does that make sense? Okay. My advice to you guys, especially as you're practicing some of this stuff, if you have colors, great. Worst case scenario, and actually it might not be a bad idea, is just do each step in pencil lightly. Does that make sense? And then you can just erase all the little movements and stuff and just leave your final graph on the page. Okay? Okay, let's do number 5. We'll end with that. Okay, we're not going to finish everything today. Actually, the next couple of pages will be very simple compared to this, but let's just do number 5. Okay? So first, for number 5, I'm going to write this in the normal order. Do you guys know what I mean by that? What don't I like about how this is written here? The x is in first. So I'm going to move it to the front. So that x now goes to the beginning, and it's negative x, and then the 2 is positive. And then we still have a plus 2 on the outside. Everybody good with those? Okay. Now, before we start figuring out, are there reflections, are there stretches, are there, translations, we always want to factor the inside before we graph. So if there's anything in front of this x, we're going to pull it out. So I'm going to take this negative sign out of there. Okay? And so now what should be left in here? What happens to x? Now it's just positive. And now this positive 2 is minus 2. And we still have the plus 2 on the outside. Everybody good with that? Okay? Do you guys see why this step is huge, the factoring that thing out? Because right now, this looks like a shift left 2, but really, it's going to be a shift to the right 2 units. Okay? So now let's write down the order. Are there reflections? Yes. How many? Over everything, right? We flip over x and we flip over y because we got a negative right here in front of the function, or in front of x. Then we got a negative outside of the radical as well. So we're going to reflect over x, yeah, and y.
In the first step of your work, you flip the negative x into 2. Is that just to make it easy for yourself to look at?
Yes. Because we're used to seeing the x first thing in the radical, right? So might as well make it look like something that you've seen before so that you don't get confused. Okay? So we reflected over x and y. That was these two negatives, right? Now, is there any stretching at all? Any multiplying or dividing of coordinates? Okay, I agree. No. So what's left? So how do we move? This minus 2 moves it 2 to the right. So right 2. And this plus 2 on the outside moves it up 2. Okay, let me make sure there are no questions so far. Okay, writing out all these details is going to help you make sure that you have a nice graph at the end. Okay, yeah.
So when it's the number is outside the parentheses, it's
Up or down.
Up or down.
Yes.
Inside it's left or right.
Yes. Okay. What's the parent graph here? What function are we flipping around and moving around here? Just the square root of x. The minus 2 is what moves it, right? We're looking at its core, like what family do we see? We see a radical, it's just a square root. Like for example here, what parent, let's do that, because if we can't identify the parent graph, we're in trouble, right? What parent graph is this going to be? Just x squared, normal parabola. It's going to get shifted around and all that stuff, but it's a parabola, right? What about this one? What's the parent graph here? Absolute value of x. This one we already did. Do you guys see how that works? Keep it very simple and then move everything around. So let's start with the parent graph. The square root of x, hopefully you know that it looks like this. If not, just do a few points real quick. The square root of 0 is 0. The square root of 1 is 1. The square root of 2, not good. 3, not good. The square root of 4, what's that?
2.
So hopefully that jogs your memory and you're like, oh yeah, that's this one. I can't do what I do with the cubic because you cannot square root negatives, right? Does that make sense? So this is the parent graph. And now we're going to do all these steps. Okay? Why don't you guys actually take a minute or two and see if you can do all these little steps to get the same final picture I'm going to have in a minute. No, Ivan. So if you want to check, all I've done so far is done the first two reflections. Do you guys follow how I labeled it there? The first thing I did was flip over y, and then I flipped over x. So here's where I'm currently at after I do both reflections. Everybody have that? Did anybody reflect it in a different order? Everybody did it the way I did? Will it matter? No, because if you flip over x and then flip over, I mean, you still end up in the same spot. So it doesn't matter what order you reflect in. Okay. Next, we're just going to move right to and up to. Okay. So now I'm just going to do that all in one step. Do you guys see the main 3 points now? Right here, right there, and right there. Okay. I'm going to just take each single one of those and move it right to and up to. So right to, up to. There's the new one. This one goes right to and up to. So there's the new one there. This point goes right to and up to. And so now here's your final graph.
So which points do you the last one?
Yes, always, yeah, it builds on the function. So after you do step 1, the next step you do is based off of that. Does that make sense? Once you do step 2, the next thing you do is based off of your most recent picture. Always start, and see, that's the mistake I made with the table. Okay? Except if you do it graphically, then you'll definitely get it wrong. All right? Any questions on that? All right, so tomorrow, here's the plan.